Welcome to MyProjectBazaar.com. Let we discuss about the process recognizing common CT imaging signs of lung diseases through a new feature selection method based on Fisher criterion and genetic optimization. Let us see the abstract of the process recognizing common CT image signs of lung diseases through a new feature selection method based on Fisher criterion and genetic optimization. The classification of medical images selection of the optimal features improves the performance of the classification process. The selection of the best features reduces the time complexity and algorithm complexity of the overall process. CT images were used for the identification of the diseases in lung images. Features were extracted from the images based on BHOG features, wavelet features, LPP features, and CVH features. The feature selection process is employed based on the genetic algorithm in which the Fisher criterion is employed as an objective function. The selected features were then classified using 5 different classifiers to test the efficiency of the selected features. The overall performance of the processes is measured based on the performance metrics. The main objective of the process is to select the optimal features from different types of the features extracted using different methods. To compare the performances of the different classifiers based on the selected features, performance metrics were used. To extract the different types of features like texture based, intensity based features, several feature algorithm methods were used. To employ the best fitness function based on Fisher criterion, the selection of the optimal features were done. To combine the fitness functions with the genetic optimization methodology will improve the efficiency of the genetic algorithm. The objective functions were initially defined, and based on the initial objective function value, genetic algorithm steps were employed. Mutation and crossover steps were the basics in genetic algorithm. In crossover, new population of genes were initialized by modification of the previous population of the genes. After the crossover, mutation is employed. In crossover, child chromosomes were created. In mutation, the crossover steps stops. The stopping condition is verified and the process is repeated till the stopping condition is reached. The selection of the selected features were then classified using different classifiers like SVM, bag of features, naive Bayes, KNN, Addons in order to compare the performances of the classifiers. The performances of the processes were then measured using metrics like accuracy, sensitivity, and specificity of the classifiers used. Let me see the flow of the process. The input CT images were obtained. From the input CT images, the features were extracted based on BHOG features, wavelet features, LPP features, and the CVH features. After the extraction of the 4 types of the features, the overall they are combined to form the test image features. Then the next feature selection process is continued. So in the feature selection process, we use Fisher criterion based genetic optimization. So in this process, the following steps were included. So in this step, first the population is initialized. So after the initialization of the population, fitness functions were calculated. So first we can check whether the convergence is achieved or not. So if the convergence is not achieved, means we move on to the crossover and the mutation process, and then the fitness function is initialized, and this iteration goes on till we achieve the convergence step. So here the convergence represents the minimal optimization function that we have got. After that, the classification process is employed. So in the classification process, we use 5 different classifiers: SVM classifier, so bag classifier, navy Bayes classifier, KNN classifier, and Addons classifier. So these classifiers are used to identify these 9 types of diseases in the input CT images. So we contain dataset containing these 9 diseases in our dataset. So finally, the performances of the process is measured in terms of accuracy, sensitivity, and the specificity of the overall process. Let me see the running procedure of the process. If you want to run the code, select the file main guy which is present in that source code folder. The other files were the subfunctions used for our process. So this is the main function. So right click it and click on run file. The process will get started. So first select any one of the input images which is present in the dataset. After selecting this input image, the process will go. So this is the input image that we have selected. After that, the region of interest, that is the region which contains the lung portion alone, is selected in this input image, and we get this region of interest image. And after that, the HOG features were extracted from the selected region of interest. So the four different types of features like feature extraction goes on. So in the BHOG features, so first this is the HOG feature extractor, and after that they extracted the HOG features were then employed the DMM clustering, and after that based on that the codebook is generated. So after this process has been completed, the BHOG features where extraction is completed, and after that wavelet features were extracted. So these are all the wavelet features extracted. So this wavelet features denotes the mean standard deviation of the wavelets extracted in three different types of wavelets. So after the extraction of the wavelet features, LPP features were extracted. This is the LPP image, that is we extract the patterns from the input images based on the local binary pattern, and the extracted LPP images from the extracted LPP images, these LPP features were extracted from the input images. So after the extraction of the LPP features, the final features, that is the CVH features, were extracted. So this is the extracted CVH features. So these features were all combined to produce a feature vector of a very large size. So we have to minimize it by using our optimization process. So first the genetic optimization process along with the Fisher criterion is employed. So this is the genetic optimization toolbox. In this we have to give the fitness function. So the fitness function has to be defined as this, that is we have to give at selection, and we give the number of variables as 1, and after that the fitness function processes will get started. So and this process will goes on. After it has been completed, the next process will continue. This will take some. So after this optimization has been completed, the next process, that is the selection of the features is. So after optimization, so this is the fitness values and everything obtained. So in the first iteration, this is the crossover population, this is the mutual mutation population, and this is denoted here, and the algorithm converges at 5 steps, and the final fitness value is 6.814. So based on this, the next process is done. So these are all the best features selected from the training features and also the testing features. After this, these features were used for the classification process. So this is the classification process. So we have used this 5 different classifiers. So each classifier identifies the disease. So after this, the performances of the classifiers were measured. So this is the clustering of the identified classes. So after that, the performance measures were measured. So these are all the performances measured, that is accuracy, sensitivity and specificity of the classifier. So these three were measured for all the 5 classifiers. So as we can see, for SVM classifier the accuracy is improved, and the sensitivity remains the same for everyone, and the specificity is also improved for the SVM classifier. So thus we have extracted the features from the CT images, and the extracted features were classified with the help of 5 different classifiers using the 4 different types of features, and the best features were selected using genetic algorithm using Fisher criterion. Finally, the performances of the process is measured. Thank you.